1.
Let's move the screen up so we can see something. Believe we have it. As you can see, we have a delta x here in this term, and then we have two delta x's here. So since we have this delta x down here in the denominator, we can go ahead and cancel out one up here and one in this term right here, and then we'll rewrite it. So let's go ahead and do that. And we'll just write it all on the same line. And if I get rid of this, yeah, we'll just, okay, so we're going to have 6x, and that delta x is going to cancel out, plus, and then we'll have the 3, and then delta x, whoa, I didn't mean to do that. I meant to put a delta x here. Which so I've learned to use shortcut keys on everything, so I don't have to use a mouse. I don't know. It kind of helps out. What we'll do now is go ahead and do the direct substitution, taking 0 and plugging it into delta x right here, and we'll be done. So we'll have 6x plus 3 times 0, and of course 3 times 0 is just 0, so we're just left with 6x. We're left with 6x. So finally, we went up here, we found the derivative. The derivative is 6x. We can now come in here and say 6, plugging 0 in for x, and of course that gives us 0. And as you can see, that the slope of the tangent line is going to be 0 at the point 0, 1. We'll go back up to the graph and take a look at this. Right, so here's the you can see here, here's the tangent line as I toggle along here. And right here at the point 0, where x is 0, of course y is 1, but the slope of the tangent line is 0. Right. It's pretty cool. Okay. And I believe now we're going to be, we got one more. One that's a little bit more difficult, and that'll be that'll end this in this section on finding the slope of the tangent line at a point.